Okay, we're going live now.
Okay, it looks like it's working.
Mm-hmm.
Okay.
All right. Hello, everyone. Sorry if this was a little quiet. We had a little audio issue here. So, welcome again to our Banarian Archaeology Research Center virtual lecture series. Oops, sorry about that. Welcome. So I have another computer and the sound was on. All right, so welcome again to joining us to our virtual lecture series. Tonight, our speakers is our very own Dr. Jeffrey Splitstoser. It's really exciting because finally we're able to present to you a lecture on one of our specialty areas, research areas at the Banarian Archaeology Research Center, that is Andean archaeology. And so, as you may know, at the Banarian Archaeology Research Center, we focus on the southeastern United States, Mesoamerica, defined broadly, and the Andean world. We obviously have a certain focus on the Maya world, but we're trying to be more inclusive of other disciplines. And so our most prominent members of our board who does archaeology outside of the Maya world is Dr. Jeffrey Splitstoser. So Dr. Jeffrey Splitstoser did his master's degree and PhD in anthropology at Catholic University of America in Washington, D.C. His dissertation is a study of the early Paracas textiles from Cerrillos in the Inca Valley of Peru. He was the very first scholar to use the George Stuart Residential Library to work on his dissertation back when Dr. George Stuart was still with us. In fact, George Stuart appointed Dr. Jeffrey Splitstoser as the vice president of the Banarian Center, as it was then called. Since then, Splitstoser and our current key person at the center, Dr. David Stewart, are in charge of our two peer-reviewed journals or publication, Ancient America and the research reports on writing. Splitstoser is an assistant research professor of anthropology at George Washington University. He is also a research associate of the Institute of Andean Studies located in Berkeley and a Cosmos Club scholar. Splitstoser was also a junior fellow at Dumbarton Oaks Research Library in 2005 and 6, where he worked on his dissertation. As a specialist in ancient Andean textiles, he is part of the Castillo de Huarmey archaeological project, which has been working on Wari sites and finding amazing Wari textiles in Kipus, which were featured in a National Geographic magazine back in 2014, and which we will be hearing more about today. Splitstoser recently received notoriety as a textile specialist for the Huaca Prieta archaeological project, directed by Dr. Tom Dillahey, where he studied, believe it or not, 6,200-year-old cotton textile that was dyed with the world's earliest evidence for indigo. So I'm Maxime Lamoureux-Saint-Hilaire, the president of the Banari and Archaeological Research Center board, and I'm delighted to introduce the vice president of our center, Dr. Jeffrey Splitstoser. Please join me in welcoming him and Jeff, the floor is yours.
Okay, thank you, Max. And sharing the screen here, and let's see. So before I begin, I wish to thank you, Max, for inviting me, you and the board, for inviting me to give this talk and to talk about Wari Khipus, which is something I never get sick of discussing. And these are some of my sponsors and collaborators. Khipus are essentially three-dimensional devices made of cords whose colors, knots, and position convey information. The word Khipu comes from the Quechua word for knot, but most of the information in Khipus comes from color and cord placement, while knots convey quantitative information. So color conveys qualitative, knots convey quantitative information. While the Wari most likely invented Khipus, what we know about them comes mainly from Inca and post-Inca sources. The Inca Empire began in 1438 and ended with the Spanish conquest in 1533. At the time of contact, the empire spanned most of Western South America, as you can see in these maps. This is an area as long as the United States is wide and about the same size as the Roman Empire was at its height. The Incas integrated their empire with more than 2,600 miles of roads, which is what these maps are showing, that ran from north to south along the spine of the Andes and along the Pacific coast with connecting roads in between, kind of like a ladder. And all of this was built without the aid of the wheel or iron in less than 100 years. Khipus were carried along the Inca road system by relay runners called chasquis, who were positioned at approximately 1 to 2 mile intervals all along the highway. They ran over some of the most extreme landscapes on Earth, from rugged mountains in a high Sierra that above the tree line to tropical rainforests and dry deserts, some of the driest deserts on Earth. Yet the Chasqui communication system brought information to the Inca Empire from almost anywhere within days. While there are many more aspects of the Inca Empire worthy of mention, this talk is about Wari Khipus, which are lesser known. The Wari Empire formed South America's first empire, which existed approximately from the years 600 to 1000 of the Common Era and included most of present-day Peru. The Wari were contemporaneous with the Tiwanaku state, which existed to the south. Together, they spanned much of what the Inca Empire would become, although the Inca Empire was larger than the two of them combined. The Wari were possibly best known for their colorfully decorated ceramics, such as these shown here, metalworking, stone carving, stone and shell inlay, and textiles, and their beautifully four-cornered hats. As you can see, bright colors are a defining feature of Wari material culture in general, and color is one of the most important features of Wari Khipus as well. Perhaps the Wari's greatest accomplishments involve their building programs, which integrated the empire with roads and agricultural terraces. They built on a truly massive scale. This is a Wari aqueduct. Most of the Wari constructions lie buried under Inca construction, so it's often difficult to know the exact extent of Wari building structures. But to get an idea of what they were able to do, take a look at the site of Piquillacta, located just south of Cusco at around 9,000 feet above sea level. By the way, I didn't point out, Cusco is right here, so Piquillacta would be around here. It's located around 9,000 feet above sea level, and it was a large Wari ceremonial site, not a habitation site. It had stone walls some of which were over 3 stories high in places. And to give you an idea of what the walls were like, this is me standing at Pikiakta underneath one of these walls. And this line here represents this corridor right here. Right, you can see it right here. It's absolutely massive. And the site covers 64 hectares and is nearly half a mile wide on one side. And it was about to be doubled, as you can see here, before the site was abandoned. The Wari, I show you Pikiakta because the Wari capital, which was located in the Ayacucho Valley and also was called Wari, its downtown covered more than 2,000 hectares. There is no complete map of the Wari site, but population estimates based on what has been surveyed suggest it was home to about 70,000 people. And just for comparison, the roughly contemporary Maya site of Tikal was slightly smaller, covering approximately 1,600 hectares. Yet the building programs at Pikiakta were much denser, as you can see in these two ovals. The Wari Empire lasted for about 400 years and was almost certainly administered with the aid of Kipus, which may have been invented for that purpose. As I mentioned earlier, what we know about Wari Khipus mainly comes from our understanding of Inca and Post-Inka Kipus, which come in several types, like the ones shown here, where each genre or type would have contained different kinds of statistical or narrative information. The most common type of Inca Khipu, sometimes called the pendant or standard Inca Khipu, has a main chord that begins with a knot called a kaite and ends with a long dangle end or tail. And here's an example of such a Khipu at Dumbarton Oaks. Kaites is like the one shown here from the site of Coyata. It's a post-Inca Khipu. They came in many shapes and colors and indicated the beginning of the Khipu, the start of the Khipu. So you would read from the kaite end to the tail end. And it would also indicate its subject matter. When Khipus were stored, they were rolled up, coiled, and the kaite would stick out. Unfortunately, in this example, the kaite is missing, but you can get an idea that you would have been able to see it. And so it served as an identifier, much like the title printed on the spine of a book. Subsidiary chords were attached to, pendant chords were attached to subsidiary chords. Pendant chords were attached to the main chord, and subsidiary chords were attached to the pendant chords. And subsidiary chords could have subsidiaries of their own up to 12 levels. Some Inca Khipus, including this one, have the one shown here, have top chords or summary chords, which are attached pointing up. The knots found in top chords represent the sum of the knots found in the group of chords associated with the top chords. So here the top chords are placed in the middle of the group, but in some cases the top chords have a loop that goes around the chords in which they summarize. The Inca used a base 10 positional numerical system to convey quantitative information, where the top registers represented powers of 10, and the lowest registers represented units from 1 to 9. So here you have your units 1 to 9, and your tens, 100s, and thousands, somewhat like an abacus. Figure 8 knots represented the number 1. Long knots represented units from 2 through 9. And in this example, this long knot represents 3, 1, 2, and 3. The number of loops represent the actual number. Overhand knots represented 10 and powers of 10. The absence of a knot represented 0. So the Wari did use they understood the concept of 0. And so in this case, you would see you would only see figure 8 and long knots in the slower register, where the upper registers would have only overhand knots. And in this, so this is an example of the number 1532, where you'd have 1 in the thousands, 5 in the 100s, 3 in the tens, and 2 in the ones. And the top chords work, unfortunately this is in my way. So in the top chord, if it were to summarize these, the chords that it's looped around, the sum of 10 plus 20 plus 100 plus 1000 plus 1532 is 2662, and that's what you see here, 2662. So that's how the Inca numerical system works. Individual chords, most of which are made of cotton, come in monochrome, barber pole, mottled, and segmented patterning, where the segmented chords represent chords that change color along their length, usually, and that change in color is from an interlock. Chords can have, but it's important to remember this because Wari Khipus are slightly different. Chords can have natural and or dyed colors that include, in Inca Khipus, white, brown, black, pink to red, orange, yellow, green, greenish blue to blue, olive, and gray. Color was used to convey qualitative categorical information. For example, pendant chords in standard Inca and post-Inca Khipus can have banded or seriated patterning. And this is an example of a banded Khipu in which there are multiple groups, each of which is defined by a specific color. We know based on research by Sabine Hyland, Julio Teo, and Gary Urton that each colored band represented an individual member of a community. And the bands were, this is, by the way, is in the standard Inca type. It's for some. We don't know if this is the case for all, but at least in some Khipus, the colored bands represented individual members of a community. And the bands were presented in order of age or time they joined these communities. So in other words, each one of these bands represented a person whose seniority is represented in the order of the band placement. We also know that standard Inca Khipus often recorded community obligations. So that meant that the numbers on the chords represented, and each chord represented an obligation that this individual owed to the community. And these obligations were placed also in a memorized order. That's why in Inca banded Khipus, it's almost always the same number of chords in each band, because each chord represented the same obligation in each band. So the first one represented one obligation, the second one represented a different obligation, but all in the same order in each band. Seriated Khipus, on the other hand, have groups of pendant chords with 5 or 6 different colors or combinations of colors that repeat. Hyland first reported that seriated Khipus represented aggregate data in which information from banded community Khipus were summarized and recorded as higher level summaries. The 2 post-Inca seriated Khipus shown here were recently discovered in a private collection in Central Asia, along with an accompanying textile with the same colors as the Khipus. You are among the first people to see these Khipus. They have not yet been studied. In addition to knots and color, haptic or sensory perception was an important attribute, at least in some post-Inca Khipus. For example, in her study of the Khipus from San Juan de Coyata, Hyland was told, and this is a picture of Sabine Hyland, was told that she must not use gloves, otherwise she would not be able to distinguish between the different textures of alpaca, guanaco, llama, vicuña, white-tailed deer, and vizcacha, all of which held significance and were found in the Khipus. Khipus encoded a number of binary attributes, such as S and Z knot twist, S and Z chord twist, recto-verso attachment directions, and the juxtaposition of bright versus dull colors. So here, this is a diagram showing what these these attributes. And so here you have cotton versus animal hair, camelid. By the way, in pre-Columbian Inca Kipus and in Wari Khipus, we do not find deer or viscacha. It's always camelid or cotton. The color classes where you have bright and shiny colors versus dull or darker colors. Cord attachment, so this is recto, this is verso. With knot twist, when you tie a knot, one end goes over the other, creating a twist that resembles the letter Z or S, and the same with cord twist. It's not important for you to remember what Z and S look like. All that's important for you to remember is that there are two different variables here. They're binary, and one of them is almost always predominant over the other. So, okay. So these, as I said, these attributes encoded dualistic information such as moiety affiliation, which refers to the traditional division of Andean communities into upper and lower groups. For instance, Manny Medrano was able to determine that cord attachments signified moiety information in a group of colonial Kipus from the Santa Valley. This work was made possible because Urton had discovered a colonial document shown here, the contents of which he was able to match with the Santa Valley Kipus. It's almost like we have a Rosetta Kipu. Not quite, but close. And again, just so you remember, recto and verso. And Medrano was able to show that these two attributes were mapping moiety affiliations, the upper and lower divisions within Andean society. In other Kipus, however, knot direction instead of cord attachment referred to moiety. Highland, for instance, was able to match knot twist with moiety in Khipu boards, like this one in the town of Mangas, which she's holding on the left. Khipu boards were used by the clergy in the past to keep track of the obligations of parishioners. Each colored cord represented a community member whose name was written on the board next to their cord. Again, it's another example of almost like a Rosetta Kipus. These are Khipu cords, but they're just attached to a board instead of a main cord. In these, Highland found a 1-to-1 correlation between S knots with the upper moiety and Z knots with the lower moiety. By the way, she's looking at the knots that are tied at the end of the Kipus that keep them from being pulled out of the Khipu board, but these knots also represented their moiety in affiliation. In these two examples, the same referent, moiety, was indicated with two different signs or attributes, namely cord attachment in Santa Valley and cord twist in Mangas. This suggests that attributes did not necessarily have fixed meanings, but were likely flexible, changing depending on time, place, context, social circumstances, and possibly Khipu genre or the idiosyncrasies even of the Khipu's maker, called a Khipu Kamaya. I have found similar patterns in Wari Khipus, which I'll introduce to you now. Wari Khipus are the most colorful of all the Khipu traditions and are distinguished from Inca Khipus by their use of wrapping and brightly colored subsidiary cords. Inca Khipus are not wrapped. There are only about 40 examples of Wari Khipus if one includes parts of Khipus, some of which are just a single cord. Most Wari Khipus have no known provenance. Have no known provenance. Those that do, however, are in the few that do are shown here. 4 of them are in the Amano Museum that were excavated by Amano himself, and 1 was excavated from Huaca San Marcos by Ruth Shadi, And then there's another group of 20 quipus that were excavated by Milos Giersch and Roberto Pimentel from El Castillo de Warmay. Wari quipus with associations have always been found with middle horizon in middle horizon tombs and with middle horizon ceramics. All other Wari quipus lack provenance. They include 4 in the American Museum of Natural History in New York, shown here, 3 in the collections of the Dumbarton Oaks Museum in Washington, D.C., 2 in the Museum of World Cultures in Gothenburg, Sweden, 1 in the Fundación Temple Radicati at the Universidad Nacional Mayor de San Marcos in Lima, and 6 in the Amano Museum in Lima. These are 6 other quipus. Remember, Amano also has one of the only collections of provenance quipus. Several Wari quipus have been carbon dated, including 3 from the American Museum of Natural History, these 3 on top, 1 in the Dumbarton Oaks Museum, and the 1 quipu from the Radicati Foundation's collection. All dates fall between Common Era 779 and 1024, placing them firmly in the later portion of the Wari Empire. This was by the way, their expansive period when they branched out to conquer much of what is present-day Peru. Wari quipus come in at least 3 types: loop and branch, shown here, pendant, and what I call wrapped pendant. Pendant type Wari quipus are similar to the Inca standard quipu, having multiple pendant cords attached to a main cord, but with a loop instead of a kite. The wrapped pendant type differs from the pendant type only in that their main cord has wrapping between the first loop and the first group of pendant cords and between each group of pendant cords. Like Inca quipus, pendant and subsidiary cords are attached with cow hitches. Pendant cords can have subsidiary cords of their own, shown here, that can have their own subsidiaries. In this particular quipu, it only has main cord, pendant cords, and subsidiary cords, 1 level of subsidiary cords. It has its long tail and the loop start. So we would theoretically read Wari quipus beginning with the loop and ending with the tail. In the loop and branch type, pendant cords are attached directly to a loop that is made of a separate cord, as seen in the loop and branch quipu currently on exhibition at the Museo de Arte de Lima. Notice that there is a miniature loop and branch quipu attached to the main loop of this quipu. We'll refer to this again later. Like in Inca quipus, seriation is a feature found in some Wari quipus. So you can see that there are 5 colors that repeat on this quipu. There are 20 groups where this pattern repeats. But the sequences are defined by cord wrapping. So this is a model of the wrapping, how it worked, and not in the color of the cords themselves, which are usually white. Frequently, Wari quipus have what I call random patterning, as seen in this example from the American Museum of Natural History, where there is no discernible pattern of cord color placement. Some of the patterns repeat, but there's no, what I can find, and there's no order to the placement. I'm also not convinced that band patterning was a feature of Wari quipus. However, there are quipus that have sequences of cords wrapped with the same color or color pattern, but these so-called bands do not have a consistent number of pendants like you would expect. And sometimes they include a series of unwrapped pendants, as seen in this example from the Dumbarton Oaks collection. you can see that the number of wrappings is different in each one. Here's 4, this one has also 4, but then you've got 7, and you've got 6, and then 3. And then some of the, they all have, well, all but one have unwrapped pendant cords as well. So it doesn't really fit the pattern of band patterning, at least not the kind that you see in Inca Kipus. Almost all Wari pendant cords have colored wrapping over natural or white cotton, and dyed camelid hair is primarily found in the most colorful wrapping yarns. So in this case, there's the red is where you find the camelid. There's also a gold here that's camelid hair. Most subsidiary cords are not wrapped, but are usually of a natural or dyed cotton. Like Inca Khipu cords, color patterns include monochrome, barber pole, mottled, and segmented. Mottled cords generally have 2 colors, but I have encountered up to 6. Wari segmented cords are always barber pole, and unlike Inca segmented cords, which I'm showing you again here, which with the interlock, one color in Wari Khipus always extends the entire length of the cord, and so the interlock is here. Wari subsidiary cords are attached to pendant cords in a specific sequence or series that repeats, though not always perfectly, throughout the Kipus. So here I'm showing you 2 examples here. These are both Kipus in the Dumbarton Oaks collection, and I'm just showing you the first cord in this Khipu where it had, but the first pendant cord, but it has, and this first pendant cord has 5 different types of color patterning, and this sequence and these colors repeat throughout the entire Khipu, although not every type is found in every pendant. You'll see this in an example I'll show later. And in this particular Khipu, this is the photo, this is a diagram. It had 10 different color pattern types that repeated. In addition to colored pendant and subsidiary cords, knots are also sometimes colored either with wrapping or by adding another yarn, a subsidiary yarn, to create contrast. So here I'm showing you examples of wrapped cords, and this is how they were wrapped. So they would take usually camelid hair and wrap it around the cord and then tie that cord into a knot, creating a wrapped knot. In this case, they actually used raw cotton to wrap the knot in it, and this is a double knot, this is a single knot, and it's contrasted with camelid hair wrapping. In fact, I suspect this may be a feature of Wari Khipus that are wrapped where they contrast camelid hair with cotton. This is not wrapped with raw cotton, it's just unwrapped, but the first knot here is red, this one's red, and this one's gold, although a lot of the camelid hair has disintegrated over time. When adding a yarn, when adding supplementary yarns to add color to a knot, the added color, the added cord can either be interlocked here, like shown here, almost like a segmented cord, or it can be doubled. So here I call this doubling, where they take a cord, they divide it in half, and then ply it. I wish I had a diagram of this. So they would slip the cord through in between the two, between the segments of a plied cord, and then they'd ply the supplementary cord, and then they would combine the 2 cords together to tie the knot, and then sometimes the supplementary yarn would be allowed to form a separate subsidiary cord, and other times it would join the main cord and form a barber pole cord. Knot twists seemed to have had significance in Wari Khipus, possibly like it did in Inca Khipus. For instance, in the Khipu shown here from Dumbarton Oaks, all the knots in one half have an S twist, so this half, while all the knots in the other half have a Z twist. This includes the knots in both pendants and subsidiary chords, and it suggests that it might refer to moiety divisions. This Khipu, however, is unique because the majority of Wari Khipus have all or nearly all S twisted knots like this. This is the only known Wari Khipu with an equal number of S and Z twisted knots. That being said, two Khipus that I know of have mostly Z twisted knots, and they're shown here. And the loop and branch Khipu that I showed you earlier from the Temple Radicati collection has a loop pendant, and all of its knots are Z, while the rest of the Khipu have all S knots. So there's a somewhat of a binary division here. They're marking this is different. We know almost nothing about the meaning of Wari knotting practices, other than the fact that knots in Wari Khipus seem to have operated very differently from knots in Inca Khipus. For example, as I mentioned earlier, knots in Inca standard Khipus are placed in registers denoting numerical hierarchy, the ones, tens, hundreds, thousands, while Wari knots are almost always tied close to their attachment, like here in these subsidiary chords, or immediately after wrapping, like in these pendant chords. Further, as previously noted, Inca Khipus have three types of knots. They have figure eight, long knots, and overhand knots. This diagram shows the knotting conventions of Wari, Inca and post-Inca, and modern Khipus. And when I say Inca and post-Inca, I'm talking about the standard Inca Khipu. And an X indicates whether that type of knot was used or not. No X means it was not used, or that we don't have evidence for it. Wari Khipus have only, as you can see, have only overhand, double overhand, triple overhand knots, and wrapped knots, or colored knots, that are also either double or single or double overhand knots. There's one exception. The Dumbarton Oaks Khipu has an octuple overhand knot, but it's the only one I know of. In many ways, this table shows that Wari knotting practices more closely resemble those found in modern Khipus. For instance, modern Khipus do not use figure eight knots, but they use overhand knots to record numerical information using a base 10 system. I say that with a caveat because there is one instance of a modern Khipu that used figure eight and long knots, but the others none of the others do. That's according to Carol Mackey's work. In many ways, further, while modern Khipus employed a base 10 positional system, Carol Mackey showed how chord thickness rather than registers indicate numerical positions of knots. In other words, Inca Khipus had a base 10 system that was based on registers, the ones, tens, hundreds, thousands, that were like an abacus. In modern herding Khipus, the thinnest chords represent ones. So there's in this particular chord, these would be the ones, tens, hundreds. And in this case, you have, well here, let's see, so in this chord, in this Khipu, you have your ones, your tens, your hundreds, and your thousands. And they're based on the thickness of the chord, not on its position, not on its hierarchical position. And so in this case, again, you have ones, tens, and then you go up to hundreds. Let's look at another example, and don't be afraid of this diagram. I'm not going to go through all of it. This is a late 19th century herding quipu collected by Max Ule from Cutusuma, a highland Bolivian town east of La Paz. It uses chord thicknesses to indicate numerical positions or powers of 10. So in this quipu here, you have, these are the ones, these are the 10s. So you have, I'm sorry, these are the ones and these are the 10s. It's based on the chord, the thickness or the ply of the chord. So here you have ones again and 10s. And when Ule purchased the quipu, he interviewed the quipu maker and recorded the information it contained. Because of this, we can see another interesting feature of herding quipus, namely the use of chord twist and knot twist to indicate binary categories of information using a principle that Urton calls markedness. Urton suggested that binary attributes such as final twist might sometimes mark exceptional categories of information. If the normal practice is to spin Z and ply S, for instance, then the marked category would be the opposite and have a final twist of Z. In other words, if it's most common to have an S, final S twist, then a chord that has a Z twist would be marked as being different, as being exceptional in some way. Hyland studied this particular quipu with Ule's notes and determined that in a region where Z spun S ply is the normal practice, S-twisted chords indeed referred to the unmarked or the normal category, representing desirable animals such as female sheep, lambs, and milking cows. So in this case, we're looking at, let's just look at this end group here in white, milking cows. So the milking cows have a final twist of S, whereas the dry cows have a final twist of Z. Z-twisted chords are counter to normal practice, which accounted for the less desirable animals that also included castrated male sheep and the dry cows. Interestingly, the chord pertaining to semi-dry cows, cows that cannot be milked every day, has an S twist, which is the unmarked category, but it has 10 S knots here and 7 Z knots. Whereas the chord representing the milking cows, those that can be milked every day, has a S twisted chord with all S knots. So they were marking a category that's in between dry and milk with a combination of knot twists, which I find very interesting. Wari quipus also have multiple chord twists, knot twists, and chord thicknesses, like herding quipus. Here you can see a quipu from Castillo de Warme that has a pattern of S-twist pendant chords and Z-twist subsidiary chords. So this is all we have of this particular quipu. It's just a portion of it. And here you have S pendant chords and Z subsidiary chords. What's important is not to know S or Z, but you can see that they are opposite in their diagonals. They're like a herringbone. This quipu from the American Museum of Natural History demonstrates how pendant chords are thicker than subsidiary chords, and subsidiary chords often have multiple thicknesses and chord structures as well. So here you have the thicker pendant chords with the thinner subsidiary chords and the thinnest subsidiary of subsidiary chords. What we don't know, however, is whether these are marking numerical hierarchy or not. Regarding the numerical significance of Wari knots, consider that in a corpus of almost 2,600 individual quipu chords, only 3 chords have 10 knots, 2 of which are shown here. So this group has 10 knots, and this group right here also has 10 knots. The third chord that has 10 knots is shown here, but it has 2 knots that are S-twist and 8 knots that are Z-twist, reminiscent of the mixture of knots found in the Kutusuma Khipu cord representing semi-dry cows. Could this cord represent a similarly intermediary category of information or ambiguous category? I'm going to talk about this at the very end of the talk again, this particular set of 2 cords. Only 2 Wari Khipu cords have more than 10 knots. So there are 5 cords in the entire corpus of thousands of cords that have 10 or more knots. One is shown here of the cords that have more than 10. One is shown here. It has 16 knots, and here, and 7 knots here, but it's all one cord, so making a total of 23 knots. But they're divided into 2 sections, each beginning with a wrapping of brown and then blue. And each group of cords is divided into double overhand knots and single overhand knots, both of them, which to me reminds me of the quattripartite division of traditional Andean social structures. So here you have your 2 moieties, upper and lower. But in addition to having these ranked upper and lower moieties in Andean communities, traditional communities are also divided into 2 or more aylus of varying number and size, where in modern Inca society, an aylu consists of a number of unrelated extended families living together in a geographic area, in other words, a town, and following certain common rules of crop or herding rotation under more or less informal leaders. Usually these leaders rotate. And so what this might be referring to is maybe the double overhand knots refer to the upper moiety, where the single overhand knots refer to the lower moiety, and then there are 2 aylus within each moiety, which is a traditional Andean division of society. And in this case, the 2 aylus are represented by their colors. What the last cord that has the second cord that has more than 10 knots in the Yamano Museum, and it has 13 knots on one cord. Now, this is very difficult to make out, but believe it or not, this cord runs all the way through and out here. Okay, so this is the cord, and this is a line in my drawing of this Khipu showing the main cord. It's probably a pendant cord, but it has 13 knots along this pendant cord. I've drawn arrows next to each of the knots, and they are separated by 13 subsidiary cords that divide the knots into groups ranging from 1 to 4 knots. The point here is to show you that it looks as though Wari Khipus never had more than 10 knots of the same kind in a row. In other words, cords with more than 10 knots, in cords with more than 10 knots, the knots were differentiated in some way by adding wrapping either between the knots or adding wrapping to the knots, or by altering the knot twist, or by increasing the knot's complexity, such as doubling it, or by adding a supplementary yarn. The fact that knots occur in groups of 10 or less suggests to me that a base 10 numerical system was probably in practice. However, we do not understand how the numerical system functioned. For example, we already saw that Wari knotting practices are more similar to modern Khipus than Inca Khipus, and Carol Mackey found that 10 overhand knots in modern Khipus represent not 10, but 100. Could 100 overhand knots in Wari Khipus, could 10 overhand knots in a row in Wari Khipus also represent 100? Are double overhand knots double? Are they 2? Do they represent 2? Or do they represent a power of 10? We don't know. One last comment about knots and numbers involves a Wari Khipu from the Dumbarton Oaks, which hints at the possibility that 2 numerical systems were in use at the same time. We probably we previously saw this Khipu, or this portion of a Khipu, which has 5 different subsidiary chord color patterns that form a series. The Khipu's pendant chords are also divided into 5 groups. So here you have group 1, 2, 3, 4, and 5 labeled, with spaces between the groups. And you'll also notice that the very first pendant chord of each group is not wrapped. So this is the first pendant chord of group 1. If we look at the number of knots found on the subsidiary chords of the first pendant chord, this is the first pendant chord here. So what I've done here is I've labeled each of the pendant chords. There are 9 of them. I'm sorry, of the subsidiary chords, there are 9 of them. Hold on. Sorry, these are pendant chords. And there are 9 in the first group. They're always larger than the number of knots found on the other subsidiary chords, which are always 0 or 1. So the first pendant chord has subsidiary chords with the numbers 8, 1, 4, 1, and 1. Where in the rest of the pendant chords in the same group, the number of knots of this in subsidiary chords of the same color always have fewer knots. And what I quickly figured out was that that the subsidiary chords of the first pendant chord, the unwrapped pendant chord, represent the sum of the number of knots in the subsequent subsidiary chord in that group. So here, number 8 in white is equal to 2 plus 1 plus 1 plus 2 plus 1. So that's 8, 3, 4, 5, 6, 7. And then there's one more white chord, 8. And number 4, this is an easier one to see, probably 4 is 1, 2, 3, and 4. And each of the others have 1. So in this particular Khipu, the number of knots in the subsidiary chords in the first pendant chord equal the sum of the number of knots in subsequent pendant subsidiary chords of the same color within the same group. Now this works in all 5 groups. However, just for brevity, I'm only showing you groups 1 and 5. But what I also wanted to show you is that in this particular Khipu, while the order, so there's the 5 different, there were 5 different colors. I didn't attach the white chords in this case, but the other 4 subsidiary chords show up in the same order in all of the other chords, but you don't always have every chord type. In other words, this pendant chord had only 2 of the 5. This one has only 1. But you can see they always, the sums are perfect in each one. However, one of the things you also notice is that, well, the numbers 1 through 7 in this case and 1 through 8 show up in the first pendant chord, the subsidiaries of the first pendant chord. In the other subsidiary chords within the group, the number of knots is always between 0 and 2. And that to me suggests that there may have been 2 different numerical systems or systems of classification going on, where the first pendant chord is a sum, where the subsequent pendant chords may represent present or absence, 0, 1, or if for instance, like let's say we're looking at camelids, whether they have whether they're male or female. Maybe if there are no camelids, you'd have no knots. If there are camelid, you might have a 1 for male and 2 for female. Something like that may have been going on. And this holds true. I'm sorry, what I wanted to say is that this is not a common feature of other Wari Khipus. Right now, this particular Khipu is the only one I have found this pattern in. But I have not exhaustively studied all the Kipus that I have analyzed yet. So before moving on to my final example, I want to quickly summarize the different variables found in Wari Khipus, which are also found in Inca Khipus. The use of different fibers, colors, attachment, cord twist, and knot twist all seem to have marked or represented categories of information. But another attribute seems to have been at work in Wari Khipus that may or may not have been used in Inca Khipus, and that is the end knot, which is the knot that kept the cord from unraveling. And you can see in this example from the American Museum of Natural History, all the cords have end knots, and that's a feature of Wari Khipus. Inca Khipus have overhand end knots, while Wari Khipus have half-hitch end knots. And I'm not aware of anyone other than Highland's study of Khipu boards that looked at end knots, but like other knots, end knots or half hitches have an S or a Z twist. But in Wari end knots, the half hitch also looks somewhat similar to the recto or verso attachment of the cords. So I will use both SZ and recto verso in my description of them. Most Wari Khipus, like in this particular example shown here, have all S or verso end knots. As an example, let's look at the two Khipus shown here, which were donated together to the Museum of World Culture in Gothenburg. These are photos of the Khipus, and you can see that one is about half the size of the other. These are to the same scale. And here you can see my drawings of the Khipus that are overlaid or superimposed over the photos. And these are the diagrams without the photos. I'm showing you this just so you can see I did an accurate representation of these Khipus. And I will use these Khipus to look at the patterns of attributes found in the Khipus, beginning with a discussion of their knot ends, finishing up that discussion. And so here I've actually increased the size of the smaller Khipus just so that it's easier to see what's going on. And these two Khipus have very different end knot patterning. All the cords in the smaller Khipu, all of them, have an S twist or verso end attachment knots, while only the wrapped pendant cords in the larger Khipu have S end knots. So what I've done is I've grayed out the cords that don't have S end knots, and I've kept the others bright. And there is one particular color of subsidiary cord that has S end knots, and that's this color. So these are all the colors found in the Khipus. And what I'm doing here is graying out those cords that are not represented by S end knots. But all of the cords that have S end knots are the same color, which I find interesting. And by the way, that same pattern is found in the smaller Khipu right here. So here you can see the opposite, where the majority of the subsidiary cords in the larger Khipu have Z end knots. I think they're the makers of this Khipu, the maker or makers of this Khipu intentionally did this to set them apart. I really think that they were probably made around the same time because they both share the same color palette, which is difficult to do with natural dyeing. It's possible, but more than likely they were made together. They also share similar structures in their cords, which suggests that the same person made both of them. These, by the way, are the cords that are cut or unraveled, so I don't know what their end knots are. There aren't very many of them. So in addition to its smaller size, the Khipu on the left has two wrapped cords. One is a pendant cord, and the other is a subsidiary cord, making a vertical type of subdivision in the Khipus. And here Fortunately, that shrunk. I have that corrected later in the talk. So here you see a vertical division in this Khipu. This division is reinforced in its wrapping patterns, where the pendant cord wrapping, which is here, this is the pendant cord's wrapping, has an additional pink band that's not found in the subsidiary cord's wrapping, and it has a different modeled central band than the subsidiary cord's wrapping. I believe that this may mirror social divisions and suggest the evidence of a ranked hierarchy, such as the case with moiety divisions. The other Khipu has 4 wrapped pendant cords that form 2 pairs. So here's one pair, this is the other pair. And this is based on the fact that the first 2 pendant cords both have subsidiary cords, while the third and fourth do not. But the wrapping pendants and the wrapping patterns in the first 2 pendants are the same. It's this wrapping pattern, where the second 2, the third and fourth pendants, have this wrapping pattern. And that's their only difference. Where pink and blue in the first wrapping pattern are replaced with tan and green or blue-green in the second group. Because pink, which you see in the first one, in the smaller Khipu, seems to have indicated possibly a higher ranking, being the pendant cord versus subsidiary cord. Perhaps pink also marks an upper moiety in these 2 pendants and a lower moiety in these 2. By the way, there are also divisions between each of these 2, which I'm not going to get into. It's just too much to go over. So subsidiary cords, so these are the 2 main divisions. But you can see, in addition, that the subsidiary cords themselves are grouped with spaces into 2 groups. Here you can see those in the smaller Khipu, where there's one group here, and then a space, a very small space, but there's a space, and then 2 more Khipus. And then this is the pendant cord grouping, and then the subsidiary cord has one group here, and then this is another group. There is a space, so I'm not sure how they're related, but they share a common feature in that both of them have their subsidiary cords attached before the knotting in their parent cord. This is very unusual. These are the only 2 Khipus that have this pattern in either Khipu. So it tells me that they're somehow related, even though there is a space between them. But so you can see these 2 groups, 1 and 2, making 4. And this is a detail of the spaces between subsidiary cord groupings of the larger Khipu. So this is one group, second group, another. This is on the first cord, second cord PO1, PO2, these 2 groups. Notice that the segmented cords seem to mark transitions between subsidiary cords in both Khipus. And I'll go back, I'll show you. So this is a segmented cord, and this is also a segmented cord. It's lost its brown segment. This brown color is fugitive, and it disintegrated in this cord. So you see marking the start of this group and marking the transition here, that there are segmented cords, and in this particular Khipu you have segmented cords as well. This is segmented, this is segmented. They seem to be marking transitions between groups. And here you can see that these spaces now are creating a 4-part division in these 2 Khipus. The smaller Khipu groups each consist of 4 subsidiary cords. So 1, 2, 3, 4, 1, 2, 3, 4, where the larger Khipu has 3 subsidiary cords in each group. And there's a cord that's missing here. There's damage to this pendant cord. However, the larger Khipus, as I mentioned, come in 3 as if the Kipus may be representing either different aspects of society, or maybe one is representing, maybe they're representing two groups. But as if they weren't complicated enough, they're knot structures, double versus single. So these are double knots, these are single knots. And always the same color of cords have double knots, where the other cords have single knots. And this is the case even in these lower subsidiaries. And there are also further subdivisions based on the lower segments of these cords. So what's going on here? So I see that the smaller Khipu is divided into groups of 4 consistently, where the larger Khipu is divided into groups of 3, and it also has this additional segmentation where you have the very last subsidiary cords are also wrapped, making, and they have 3, and 3 of them have subsidiary cords of their own. So here you have 1, 2, 3. There's 1, 2, 3 groups, and 1, 2, 3 groups. So what we have here is a upper and lower division, possibly with perhaps 3 ILUs, where the other Khipu has an upper lower with perhaps 2 ILUs. So what's going on? I believe that this Khipu is modeling a community, but it also has many, many marked cords, like we saw in the Inca and post-Inca Khipus, and which suggests to me that that they're concentrating on marking out exceptional categories, possibly by using camelid hair, bright and dull colors, cord twist, knot complexity, cord attachment, and end knots, all of which are present here. So this Khipu also displays not numerical patterns, where the majority of cords have either 0, 1, or 2 knots. So most of the cords, 12 cords have 0 knots, 21 cords have 1 knot, and 4 cords have 2, which is the majority of the cords. But also interestingly, 5 cords have 8 knots, and 8 cords have 5 knots. And I find this curious because the numbers 5 and 8 are prominent in the upper registers of both Khipus, but in particular of the larger Khipu, and we know that the number 5 and 8 are important in calendrical information in the Andes, where Tom Zeidema, who cited Pizarro, noted that the Inca one of the versions of the Inca calendar consisted of 41 weeks of 8 days, forming a lunar calendar. And here we can see something like that going on, where if you have 8, these are each 8 knots, and these are 5 knots, and then there's 1 additional knot tied above them. So if you have 8 times 5, which is 40 plus 1, that gives you 41. And there are 4 series of these, and it's if you double it, you're getting 8 knots, or 8 times 41. So it's possible that there was some sort of a lunar calendar going on, but it's also possible that there was something else happening, and that could be that there's a well-known relationship between the numbers 8 and 5, where 8 years of a Venus cycle equals 8 solar cycles equals 5 Venus cycles. And while I haven't been able to confirm this, I told you I'd return to those 2 subsidiary cords that were very strange and unusual. That there's and I puzzled over this for a while, that these attachments are contrary to all the other attachments in the Khipus, and contrary to almost all other attachments in all Wari Khipus, because the subsidiary cords are attached before the parent chord's knots, which is backward to the normal order. If this Khipu is somehow related to Venus cycles, which again, this is speculative, could these chords possibly represent the retrograde motion of Venus when it appears to move backward in the sky? Further, Venus is typically not visible for about 8 days during its retrograde, but this is somewhat variable from year to year. Retrograde is when it moves backwards. So the red chord with 6 knots and the brown chord, the brown and white chord with 10 knots, possibly could represent this retrograde uncertainty. Remember also that 8 of these knots are S and 2 of them are Z. So, and if you average 6 and 8, that 6 and 10, that's 8, and you had 8 that were S and 2 that are Z. If this particular register tracked the retrograde of Venus, it would seem then that spaces between groups of subsidiary chords and Wari Khipus might mark changes or differences in what is being represented. In other words, this pattern seems specific only to this particular group, which again is marked by a segmented chord. And so these groups of subsidiary chords might be representing different actions or different kinds of accounting that so one Khipu may have multiple types of information within it. So in conclusion, I hope that I've demonstrated that there were multiple genres of multiple Khipus, including pendant, loop and branch, and Wari and wrap pendant types, each capable of recording very different kinds of information and possibly multiple types of information within the same Khipu. Further, binary attributes of color, chord twist, attachment, knot twist, and knot structure, such as single and double knots, were used in Khipus to mark categories of information while simultaneously mirroring their relationships and structures within their societies, such as upper and lower divisions, ILUs, desirable and not desirable attributes, etc. This likely gave Khipus a familiar logic that aided in both their making and reading, and it probably provided important clues needed to match color patterns with reference while avoiding mistakes. In addition, the maker or makers of the Göteborg Khipus seem to have added meta information in the form of segmented chords placed between the subsidiary chord groups or registers, perhaps as a reminder that something had changed. Using segmented chords to represent change makes sense to me since segmented chords themselves change in color. I hope I have conveyed to you also that the sophistication of Wari Khipus and how they most likely were capable of recording anything of importance to the Wari, including anything that could be written. Their utility is evident in the fact that they were used by both the Inca to run one of the largest and most complex empires of the ancient world, and their use continues up to the present day. So before ending, though, I'd like to quickly thank the Boundary End Center again, and I also wanted to tell you about what's going on at the Boundary End Center. In addition to our workshops, publications, and research facilities, we're building programs to support scholars in their research on the ancient Americas. Our current George Stuart resident scholars are Nelda Isa and Ashuni Romero, who are doing fascinating work. We have big plans for the future of the center, including renovations and financial support for residential scholars, and your donations go a long way to helping us achieve these goals. The Boundary End Center is a 501c not-for-profit organization, and any amount you can give helps. Through May 31st, you also have the opportunity to double your donation. The Gene D. and Charles M. Calvert Memorial Fund will match all gifts to the Boundary End Center up to $25,000. If you would like to donate, there is a link below the YouTube video if you click Show More, or you can go to boundaryend.com. And mark your calendars for April 21st, when Nelda will be giving our next virtual talk, which will be about non-funerary human assemblages from Chichen Itza and its immediate area. Thank you.
Thank you, Jeff. This was highly technical and interesting. No, that's all good. It's a true science you're developing there. And it's impressive how it's basically a sort of epigraphy of textiles there, where you really are dealing with complex information systems that are encoded in these. I echo you in saying that we are very thankful for anyone who can donate to Banarian Center. We really can use any funds you can send our way, and this doubling of funds makes this a unique moment to donate, right? Because everything gets doubled. And thank you so much to the Calvert Fund for this. Without waiting too much longer, I would like to start a Q&A because we have some great questions from the public. I probably won't have time to answer all of them, but in interest of time, Jeff, I would like to ask you to try to make the answers not super long, just so that we can go through a few of them. So the first question comes from Felix Navarro Grau, who is asking simply, what is the oldest dating there is of a Khipu?
The oldest that we have right now, I think, was 771, a common era, and that was the lower range. The 779.
And those are also Wari. There's no Khipu that
they're Wari. We don't have any Khipus prior to Wari.
Okay, that's very interesting. Okay, thank you. Now, as related to this this question, someone Mac Fitzpatrick was wondering, where can we find the published radiocarbon dates for the Khipu that was mentioned?
Oh, that's a good question. I didn't list the carbon date reference, but they are. I'm not sure how I can make those available. I have not published them myself. But they're available publicly.
Do you know if you have the name of the author who published the radiocarbon?
Well, I don't know if any of them have been published.
Okay. Well, if someone is aware of that, please, if someone knows the study, maybe write it down in the chat. Thank you, Jeff. And then maybe we can send information about that in a future newsletter. Which reminds me that I should mention that before John gets mad at me. Please subscribe to our channel if you haven't done so already. It really helps us get some exposure. It's very simple. Just click subscribe at the bottom there. All right, so next question comes from Monica Medelius, who asked a few questions. So I'll try to package two of those in one for you. First part is, in what archaeological context were the Wari Khipu found, and is there any information in any colonial archives regarding how Wari used their Khipu?
Okay, so there are three sources of Khipus that have provenance. One of them was excavated from a tomb by Ruth Shadi. All three groups were found in tombs. They were always found, other than the one Khipu found by Ruth Shadi, the two other finds are groups of Khipus, multiple Khipus. One of them comes from Castillo de Guarmey, which is on the north central coast of Peru, and it was a mausoleum. And the other comes from the Ica Valley, and it was a looted tomb, and they had left the Khipus, and they were literally stuck apparently on the sides of the walls. And Mario Amano's father, the founder of the museum, he actually went into the tomb and picked them off. Mario remembers, he told me he remembers watching his father picking these Khipus out of the walls of the tomb, and that's how they were saved. So they all three have burial contexts, but we don't have any transcripts from Wari Khipus because the South Americans had no writing system. And in fact, the Incas had no writing system. And what we have mostly, a lot of what we know about Inca Khipus comes from Spanish documents, Spanish written documents.
Okay, thank you. Someone suggested that the person who may have, George Lau was suggesting that a person who may have published those dates is Gary Urton in his Antiquity article, From Middle Horizon Core Keeping to the...
Oh, yes, yes. He did publish, he published the 3 dates of the, or he published the dates of the 3 Kipus that were dated from the American Museum of Natural History. That's right. But the one date is coming, one of the dates is coming from the large Wari Khipu at Dumbarton Oaks. And that date was paid for by Bill Conklin. It was privately done, and he never published that. And the second date comes from that loop and branch Khipu from the Temple Radicati, and that's a recent date that they may have on their website. I hadn't thought of that. So it's the Mali, M-A-L-I website. It's for the Museo de Arte de Lima, and that Khipu is on exhibition, and they're probably, it's not published like in a book, but it's online, probably published there. But it's a new date.
And as a small note, while the research of Gary Urton is relevant to this talk, he is in no way affiliated to the Boundary and Archaeology Research Center. Then the next question comes from Alvaro Martinez, who is saying, I recently discovered the existence of the Nepowal Tzintzin. They were similar to Khipu, like knotted strings found in Mesoamerica. There's an author named Boturini who claimed to see one himself in Tlaxcala. Is there any study having that has looked at possible relations between this Nepowal Tzintzin and the Khipu?
I'm not aware of any. In fact, this is the first I've heard of them. So that's really interesting to me, and I appreciate the mention. In fact, if you'd like to contact me, that would be great. But I have, using knotted strings is not unique in the world. Apparently the Chinese used knotted strings as a communication system prior to their inventing their hieroglyphic system, and other cultures used knotted strings as well as an information system.
And then someone else was saying, Mayor Walker was saying that maybe this Nepowal Tzintzin, was more like an abacus style device. So maybe it's somewhat similar in function, but maybe different in technology. Then George Lau is asking, are there any clues from the Wari examples that might relate to ancient language use, like the 2 numerical systems or even other semiotic practice? Saying maybe the haptics. I'm not sure what haptics are.
Well, I think that's a really excellent question. Thank you, George. And I would love to talk to him about it. I have to admit, I don't know enough about Andean languages to confidently make an answer to answer that. I do know, the only one thing I do know is that in modern Quechua that it apparently has a built-in dualism within it. And so I think perhaps it's all related. Their societies, their language, and the Kipus themselves may all be interconnected. And there probably are relationships between them. I mean, like in Maya writing, in Chinese writing, they're not just symbols, they also carry phonetic information, and there may be puns, like that may be in place that need to be discovered. But we don't even know really what language the Wari spoke. Some people think it's Aymara, and some people think it's Quechua, and some people think it's Burkina. We don't even know for sure. I don't know for sure. Maybe George has a better idea.
Okay, thank you. Then another question from Christian Klados from Marburg, Germany. Says, great talk, thank you. Are there iconic elements in Wari Khipus like dried potatoes or llama ear tips, as there are in modern Khipus?
So I have not ever seen any attachments in Wari Khipus, not yet anyways. The way we define a Wari Khipu, by the way, just so you know, is that we see them in that they have wrapping, and that they have the knotting system, that comes immediately after the attachment of a subsidiary cord, or right after wrapping. It's quite possible, that there are Khipus out there that were made during the Wari Empire that we just have not recognized as Wari because they don't fit into what our notion is of a Wari Khipu. Like I mentioned, there are multiple genera of Khipu, many genera, and that's been a problem that I think Sabine Hyland has been so influential in, and that she has taken a lot of Khipus that other people had dismissed as not being Khipus, and she's shown that they really are Khipus, that they're different genre. And I think, while I'm confident that the Khipus I've studied are Wari Khipus, I'm not confident that there might not be others out there that I have not recognized as Wari Khipus.
Thanks. And then regarding one of your earlier, sorry, there's a couple other questions that came from the same individuals. But one was kind of related to one thing you just said. It's a quick question. So Monica Medelius was asking, also was commenting basically that Wari people spoke probably Aymara, and then Chinu is the word for not. Shouldn't their registers be called Chinu rather than Khipu, which is Quechua?
Probably, if we can be absolutely sure that they spoke Aymara. You know, I am aware, you know, of the arguments of Aymara speakers. So and I lean towards that too, but I don't want to say that that's what they spoke, because you know, this is we really don't know.
Yeah, it's a little like we have in Mesoamerica. There's several civilizations with which we're not sure what language they spoke.
Yeah.
For example, the Olmec, we really don't know, and so that we can decipher the writing system. Similar situation, but not quite the same with Teotihuacan.
I think we would be. I think if we could find something like George Lau was referring to or was asking about, if we could find an attribute that may give us a solid clue that this is representing an actual word, that may help us. That may then unlock that mystery. But I wouldn't right now. I don't know what to look for. Right? But I'd love help.
And then Mac Fitzpatrick was also asking, has any analysis been done on what specific pigments were used for dyeing Khipu cords?
So with Wari Khipu cords, no. But there are a lot of studies going on actually right now looking into the Inca and post-Inca Khipu dye colors. In fact, I've made a replica of a Khipu based on some of this information for post-Inca Khipus that's currently on display at St. Andrews University in Scotland. And the reds would have come from cochineal. The yellows we're not sure of, because yellow can come from many different sources, and so yellows tend not to be analyzed. The blacks are probably coming from tannins, or they could be natural camelid hair. And the blue, of course, is indigo. And the blue greens could be indigo or a combination of colors. Basically, those are the primary. Those are the colors that have been identified so far. But and I suspect in Wari Khipus, because they're so brightly colored and yet they're mostly made of cotton, that they were using ochres to color them, because it's very difficult, for instance, to get a bright yellow in cotton unless you're using an ochre. And you have bright yellows, for instance, in the Dumbarton Oaks Khipu. You also have oranges and reds in the Dumbarton Oaks Khipu, which would be very difficult to get unless they were using ochre. And we were just about to actually test those cords when COVID broke out and we had to cancel it. So hopefully we'll know soon. Emily Kaplan at the National Museum of the American Indian, she was going to do those studies. So we'll see. But I would love to be able to test more. I would love to be able to analyze the dyes, and apparently there are some methods now that are non-destructive that I might be able to use using photography.
Oh yeah, I don't want to take too much more of your time, Jeff, but I'm going to finish with one question of my own. This replica of Khipu that you sent to St. Andrews University, did you make it with your homegrown cotton that you grow?
Yeah, I grew the cotton. I did all the dyeing myself and in the spinning and the plying, and it was really that Kipus could be made. Who I wasn't able to mention before. There's too much to talk about, right? I already ran over, but he did a lot of work on color in Kipus, and because he actually excavated Kipus from Inca, and they were attached to wrapped stick time. They were made in advance, and they were stored on a string that could be easily removed from and added to a pendant cord and record the information. That could have been done.
Of Khipu making. Yeah. I think that would be very interesting for sure, and perhaps Mika who have been with us today.
Bye, everybody.
Goodbye.